Lesson 12.3, Using Data Displays. A circle graph is a type of graph that represents data as sections of a circle. A line graph is a type of graph that represents data that changes over time. We use a circle graph a lot when we are talking about percentages. A line graph, if we're talking about change over time. You may want to write this down just because this is how you can identify whether or not you should be using a circle graph or a line graph, a bar graph, and so forth. In example 1, we're going to make a circle graph. A survey asked, how many televisions do you have in your home? Of the 100 people asked, 9 answered 1, 63 answered 2, and 28 answered more than 2. Display the data in a circle graph. You want to use a proportion to find the number of degrees to use to represent each response as a section in a circle graph. We are going to take the fact that there was 9 people that answered 1 out of 100. So you can think of this as your base, and then 9 is your part of the base. Here you have 9 over 100. You set it equal to A, which you don't know, the number of degrees, over 360. Remember that when you add up the degrees of a circle, it should equal 360 degrees. That's why we use 360. You can use cross products to solve this. You will get 32.4 degrees, which we can estimate to just 32. Do the same thing with for the people that answered 2 televisions, which is 63 out of 100. Again, set it equal to B over 360. Cross products, 226.8, which we can round up to 227. Finally, we have 28 out of 100. Use cross products, we have 100.8, so we can round that to 101. Just be careful, you want to make sure that 101 plus 227 plus 32 equals to 360. Next thing we do is we draw a circle. Show its center. So you basically are making a circle, and they kind of did it for you, and then you put a center in the middle of the circle. You then use a protractor to draw the first angle measure. Actually, what I do first is I just draw a line, draw your radius from one side to the center. Then I can use my protractor to measure the degrees of that, whatever I'm labeling. So if I use that one, more than 2 was 28, which is 101 degrees. 1 was 32 degrees, and then people that had 2 was, 227 degrees. Again, use your protractor to measure that. Always include a title and label each section. Okay, you don't have to label it with the degrees, you can actually just label it with the numbers. So you can see that based on the circle graph, the majority of people have 2 televisions in their home. In example 2, make a line graph. The table shows the number of visitors in hundred thousands to a zoo. Make a line graph of the data. Draw and label the horizontal and vertical scale. Okay, so on our bar graph, I'm going to make a horizontal and vertical scale. From there, I am going to label it. This is going to be my years. This is going to be my visitors. Again, why do we know that the years are on the bottom? Because in a line graph, it's always over time. So anytime you're looking at time, years, months, even minutes, days, you're going to make a line graph. And I would put time in your horizontal axis. Always include a title. We're talking about the number of people that visited the zoo. And now we plot a point for each data pair. So 1995 was about 2.4. And 96 was 3.5. 97 was 4.3. 98 was 5.8. 99 was 7.1. 2000 was 7.9. 2001 was 8.6. And then we do draw a line segment to connect the points. As nice as you can, connect them with a straight line. You can see that there is an increase over time. And there's the graph. I did a pretty good job. So the number of visitors to this zoo have increased over the years, which is always a good thing. Okay, in example 1, you need to make a bar graph. Now, a circle graph. You're not actually going to make a circle graph. What I want you to do is I want you to find the number of degrees. To do that, we use a proportion. In fact, you actually don't even, well, the proportion could be with a percentage, or you can just take the percentage equals what you want over 360. So you can see that we want to do week 2, right? Just week 2. I'll help you get started, and then you can pause the video. So 64%, you could just make it into a proportion by putting it over 100. A percentage is over 100. Set that equal to what you want over 360. Again, the other way you could think about it is actually taking, instead of doing the proportion, you could do 64%, you're going to have to change it to a decimal, and multiply it by 360 degrees. So you might want to write this down, and actually I would write this down. To find the number of degrees, take the percentage, 3%, and multiply it by 360 degrees. Or you can think of it as finding the percent first, A over B, equals X over 360 degrees. This is something you should write down because you will need to know how to find the number of degrees. Please pause the video, find the number of degrees for 87, 89, and 93 octane for week 2. For 87 octane, 64% times 360 is going to be, I'm going to write it down here, 230.4 degrees. Again, we can round that, and I would, because when you do degrees, you don't want to have a decimal. Just round it to 230 degrees. So that was the 87 octane. To find the 89 octane, we're going to take 30% times 360. So change it to a decimal. We have 108 degrees. 93 octane. 6% times 360 degrees, which is 22. I'm going to round it. It was 21.6, 22 degrees. Let's just double check that those add up to 360, which they do. Especially when you round, you want to make sure they round up to 360. Once you know your degrees, then you could use a protractor to measure and make the circle graph. I'm going to show you what that looks like. Remember, 180 degrees would be half of a circle. 90 degrees would be a quarter of a circle. So if you look at the octane, that kind of looks like a little bit more than a quarter of a circle. So that makes sense. It's 108 degrees. 93 octane was 22 degrees, and then most of it was the 87 octane. So you can see that, what does the graph show? It shows that more 87 octane gasoline was sold than any other type of gasoline. And this is like your regular or your premium gas, or super plus, or whatever they call it at the gas station. That's what they're talking about, the regular versus super plus versus premium gas. This time make a line graph for the 93 octane gas. So that is these right here. So over the weeks, now remember we have week 1, 2, and 3. So that goes in my horizontal axis. And then the percent of sales, because we only know percents. So you are going to have to go back to example 1, which might be easier for you. Week 1 is 7%. Oh, I'm sorry, pause the video if you haven't already. Plot the points and connect them. Then tell me what the graph shows. Week 2 is 6%. Week 3 was 5%. When you connect it, you can see that the sale of octane, 93 octane gasoline decreased over the weeks. Which isn't good. You never want your sales to decrease. When do you know what data display to use? This is a very important graph and representation of when to use what data. So you definitely want to make sure you try to memorize when to use what data. For example, a circle graph. Remember that a circle graph represents parts of a whole, okay? And those parts of a whole usually use percentages. They don't put that on there, but it is usually with percentages. Or at least you can find a percent because it's parts of a whole. A line graph represents data over time. So the important key word here is over time. Stem and leaf plot is used to order a data set. And the key word here is order. So your thing was percentages, or find the percent. Time and order, stem and leaf plot. Box and whisker plot shows the distribution in 4 parts. Okay, so use the median, quartiles, and extremes to represent it in 4 parts. We use a bar graph when we have distinct categories. What type of pet do you have at your house? What's your favorite color? Colors, pets, anything like that is a category. We use a Venn diagram to display data in overlapping categories. And we use a histogram. Remember the difference between a bar graph and a histogram is a bar graph has the spaces and uses categories, where a histogram does not have spaces in between, and it's used to compare the frequency, how often something occurs, of data that are grouped in equal intervals. So let's think about how to choose an appropriate data display. The table below shows the percent of holiday shopping done in stores through catalogs and online. The percents total 100%, so which one would you say would be the best data display? And again, use this graph to help you. I would say a circle graph is appropriate, especially because it totals 100%. That's important to know about a circle graph. If it totals 100%, and maybe you want to write that back here, when we did circle graphs, these would be parts of a whole, so it totals 100%. Write that down, that's important to know. And then for B, they don't total, that's more. And I would say that you want to use a bar graph because the film speed is your category.